Hello, welcome to chapter 2 of the course M132 Introduction to Linear Algebra at AOU. In this section 2.3 of the book, we will talk about linear dependence and independence. This is the last section that we talk about in this chapter. We'll start with a few definitions. Definition of linearly dependent and independent vectors. The set of vectors S, which contains x1, x2 to xk in Rn, is linearly dependent if there exists scalars c1, c2 to ck that belongs to R, the set of real numbers, not all zeros, such that c1 times x1 plus c2 times x2 plus ck times xk is equal to 0. Otherwise, x1, x2 to xk are linearly independent. That is, if x1, x2 to xk are linearly independent whenever c1, x1 plus c2, x2 plus ck, xk is equal to 0, we must have c1 equal to c2 equal to ck equal to 0, which is the trivial solution. So whenever we have a trivial solution, it means that the vectors are linearly independent. If we have at least one of the c values different than 0, then the vectors are linearly dependent. Geometrically speaking, vectors being dependent or independent means the vectors are linearly dependent if their line of action is the same. They could be in different sense, different direction, but the line of action is the same. Vectors are linearly independent from the geometry point of view if each is going into a different direction. In other words, they don't have the same line of action. Examples: the vectors x1, x2 and x3 are linearly independent. These vectors are called the coordinate vectors, and since c1 x1 plus c2 x2 plus c3 x3 is equal to 0, here we have c1 equal to c2 equal to c3 equal to 0, which fits very well into the definition. And we know that these three vectors being the coordinate vectors, each of them has its own direction. They're not on the same line of action. Another example are the vectors x1, x2 and x3, which are in R3 linearly independent. Explain. In order to answer the question, we must apply the definition. Assume that c1 x1 plus c2 x2 plus c3 x3 is equal to 0, where c1, c2 and c3 belong to R. If we multiply these constants or these scalar values by the values of the vectors here, we will have, as we have seen before in the previous page, a system of equations for which we can create the following augmented matrix, and then we can do the row reduction to obtain this matrix here. And here we can see that c1 is equal to 0, c2 is equal to 0 and c3 is equal to 0. Therefore x1, x2 and x3 are linearly independent vectors. Note that the set of n vectors S equal to x1, x2 to xn in Rn is linearly dependent if the determinant of these vectors, the determinant of the matrix formed by these vectors, is equal to 0. Otherwise, S is linearly independent. In other words, if the determinant is different than 0, S is linearly independent. Example: the vectors x1, x2 and x3, as shown here, are linearly independent since the determinant of the matrix that is formed by the vectors here is equal to 1, which is different than 0. Another note here: two vectors x1 and x2 in Rn are linearly dependent if and only if x1 is equal to cx2. One can be written, in other words, one vector can be written in terms of the other one. the vectors x1, x2 to xk are linearly dependent if and only if one of them is a linear combination of the other vectors. So if we can write one of the vectors as a linear combination of the others, then these vectors are linearly dependent. Example, the vectors x1 and x2 shown here, 1, 1, 1 and 3, 3, 3 are linearly dependent since x2 is equal to 3x1. Same thing here, the vectors x1, x2 and x3 are linearly dependent since x3 is equal to x1 plus x2. Example, let S equal to x1, x2 and x3 be a linearly independent set. Show that T, which is equal to x1 plus x2, x1 minus x3 and x2 plus 2x3 is a linearly independent set. To answer the question, we assume that T is linearly independent. If it is the case, then C1 times x1 plus x2, x1 minus x3 times C2 plus C3 times x2 plus 2x3 is equal to 0. We applied the definition. If we regroup and factor the x1, x2 and x3, we'll have the following statement: C1 plus C2 times x1 plus C1 plus C3 times x2 plus minus C2 plus 2C3 times x3 is equal to 0. We can create the system, which is a 3 by 3 system. The variables are C1, C2 and C3. From this we create the augmented corresponding augmented matrix that is equal to 0. If we do the row reduction, we obtain the following matrix, augmented matrix, which shows that C1 is equal to 0, C2 is equal to 0 and C3 is equal to 0, which confirms that T is linearly independent set. This ends the tutorial for section 2.3.